Okay, now this lesson is on 11.2, vector calculus. So vector is a way to look at another way to look at motion, and it has direction and magnitude. Yes, kind of like the cartoon Despicable Me. So we are talking about three-dimensional here because we have I, J, and K. If it's two-dimensional, it's just I and J, right? So it has two variables, kind of like parametrics, to kind of give us the motion of the particle. And the way you deal with it in calculus terms is actually very straightforward. If you're taking the limit, you just take the limit of each of the components, right? So you take the limit of each of the component. So limit of each of the components here. If you're taking the derivative, you take the derivative of each of the components. If you're taking integral, you do the same thing. You take the integral of each component. If it's an indefinite integral, you simply add a plus c at the end. If it is definite integral, you will evaluate each of the definite integral at each of those functions and then plug them in. So right here, this is exactly what we're going to do. It says to evaluate this integral from 0 to 2 of this vector function here. So what you can do, what I would suggest, is take each component and just solve the integral separately, right? So you have integral 0 to 2 for e to the 2t dt, and an integral of 0 to 2 t plus 1 to negative 1 dt. Okay, when you take the antiderivative, the first one should give you 3t to the fourth, evaluate 0 to 2, plug in the 0, plug in the 2, you should get 48 minus 0, which is 48. Second one, you get 4e to the 2t, so when you take the antiderivative, the 2 on the exponent here will come out as a reciprocal, so it's 4 over 2. This will give you 2e to the 2t, evaluate 0 to 2, plug in the 2, you get 2e to the fourth minus 2e to 0, so that's 2. So that's 2e to the fourth minus 2. Last one here, you have t plus 1 to negative 1 power. So that's really 1 over t plus 1, which will antiderivatize to be natural log of t plus 1, right? And evaluate 0 to 2. So plug in the 2, you get natural log of 3 minus natural log of 1, which is 0. So your final answer should be the components of 48i plus 2e to the fourth minus 2k. Oh, sorry, j, wrong one. Wrong variable. And then lastly, plus natural log of 3, k component. All right, so some teachers like to write this way to show you the vector because it's a little bit hard to bold your writing. So if you want to make sure this is obvious, you can do these little one-sided arrow to show your vectors. Okay. All right, velocity, acceleration, speed works as you would expect in vectors here. So they are pretty much like parametric equations, right? So here is your position functions denoted as r of t. Okay, so it says find the equation of the tangent line when t equals negative 1. So first things first, this is my x component. It's my horizontal component. So x equals 2t cubed minus 3t squared. My y component, my vertical component, is y equals t cubed minus 12t. Okay, so what do I do? In order to find the tangent equation, I need the slope, I need the point. So I'm going to find the point first. I know when t equals negative 1, I get my coordinate here. So when t equals 1, no, t equals negative 1, sorry. At t equals negative 1, I plug it in, I get x equals negative 2 minus 3, so it's negative 5. I get y equals negative 1 plus 12, that gives me positive 11. Okay, now what about the slope? Now we're going to take the derivative of each component separately. So I get dx dt equals 6t squared minus 6t. And dy dt is going to be 3t squared minus 12. So dy over dx is going to be 3t squared minus 12 over 6t squared minus 6t. Now, if you were being asked for the slope, you would totally simplify this. But because we're using this to find the tangent line, just go ahead and plug in negative 1 and figure out what the slope is. Right? So for slope is equal to 3 times negative 1 squared minus 12 over 6 times negative 1 squared minus 6 times negative 1. That will give me negative 9 over 12, which is negative 3 over 4. Okay, so your tangent equation is really y equals negative 3 over 4, x plus 5 plus 11. So that's my tangent line to at t equals negative 1. Okay. Part B, find the point where the horizontal component has 0 velocity. So first things first, you got to find the velocity. So just the same as our rectangular equation, the velocity is the first derivative of your position function. You have r of t as your position function. Therefore, your v of t is take the derivative of each component, which we already did. So that would be 6t squared minus 6t I plus 3t squared minus 12j. So that is your velocity. So find the points when the horizontal component has 0 velocity. So where is the horizontal component? That is my x here. So simply take that and find it when it's 0, right? The 0 velocity. So if you do some factoring here, you will get t equals 0 and t equals 1 is when you have 0 velocity. Okay, that is your answer for part B. Okay, lastly, part C, find the speed and direction when t equals 1. So what is speed? Well, speed is defined as absolute value of v of t, right? So it is the velocity, but without direction. So it's the absolute value of v of t. But then in these components, in vector and in vector form, this is also the magnitude. So if you're looking at the magnitude, it is kind of like Pythagorean theorem where you have the x component and the y component. So you go x component squared plus y component squared equals the magnitude squared. So v of t is really equal to your x component squared plus y component squared, square root of that. So your speed is equal to your velocity component. So 6t squared minus 6t squared plus 3t squared minus 12 squared, square root of that. Now, where am I looking at for speed? I'm looking at t equals 1. So you plug in 1 and you will get 0 squared plus negative 9 squared, which gives us 9. So speed is 9, right? There's no positive or negative answer. Well, there's no negative answer because speed has no direction, right? It's just the absolute value of your velocity. So what about direction? So direction is defined as velocity over speed, right? So it's v over the magnitude of v. So you have your velocity here, which we could go ahead and work it out here. Well, sorry, velocity, you can go ahead and plug it into your velocity function here, right? So if you plug in the velocity, you plug in t equals 1 into the velocity function, you get negative 9j, and you divide it by our magnitude, which is 9. So my direction is negative j, which means it's going down, right? So it's a vertical action, but it's going negatively, so the direction is going down, okay? All right, last one, you have v of t here. This is your velocity function, and this is kind of like the initial value function problems that we had in rectangular coordinates. It says find the position function vector, if r equals natural log of 2 of I component when t equals 1. So what you want to do is you want to take the integral because you have velocity. So in order to get position, you got to go backwards. You got to take the antiderivative and go backwards and get your position function. So your position function is going to be, if you take the antiderivative of this, your r of t is equal to natural log of t plus 1, right, I component. Take the antiderivative of 2t, that will give you t squared, j component, and you have a constant because you're taking antiderivative. Now, we are given some initial value, so we know that r equals natural log of 2 when t equals 1. So we're going to plug that in. We go natural log of 2, I, right, equals natural log of 1 plus 1, I plus 1 squared, j plus c. So we plug in 1 for t and natural log of 2 I component for r, right? So we go ahead and solve this out. We will get c equals negative j. So after plugging that in, my original function, my position function, is going to be natural log of t plus 1 I plus t squared minus 1 j component. Okay? All right. So then lastly, it says find the total distance traveled. So if you recall in last semester, when we need to find the total distance, we were actually supposed to graph this out and see where my velocity function goes below the x-axis and then kind of force that to be positive. So you kind of figure out where you cross the x-axis and then divide it into several different intervals so that you can take the negative area and subtract it and force it to be positive. So because it is hard to graph this, it would be much easier to just look at your velocity function and take the absolute value of it. Because if you're looking at total distance and look at it as the absolute value of t, right, that means it forces any negative velocity to be positive. So that will force your negative area to be positive. So you can look at it as a total distance instead of just positive, negative distance kind of canceling each other out. So for this case, in order to find the total distance, we will look for the integral of 0 to 2 of the absolute value of t, right? And so we talked about this. When it's the absolute value, it is defined as the magnitude of t. So u of v, sorry, not magnitude of t, magnitude of v. So this is really 0 to 2, square root of your x component. So 1 over t plus 1 squared plus 2t squared dt. And yes, please use your calculator. Use your calculator to figure this out. You can find the answer much quicker. And your answer should be approximately 4.335 for this. Okay, all right, that's it.